Good afternoon, everybody. My name is Rick Bakken. I'm with Microsoft, and welcome to How Microsoft Manages its Cloud Infrastructure at Scale. As you can likely tell, this next hour and 15 minutes is going to be about data centers. Let me give you a little background on myself. About 20 years with the company. I'm a data center evangelist, which means I get to do what I'm doing right now every single day, which is to talk about the assets that we're making, investments we're making basically in the data center space, and really talk about the innovation and bring our customers into the conversation around what we're doing at scale, really to enable the cloud, utility computing, a number of those types of things. The three things I'd like you to get out of this presentation are, number one, how is Microsoft delivering IT to the cloud? We're organized a bit differently. I'm going to talk about my organization, Global Foundation Services. One thing I want you to think about is we are an infrastructure provider. Data centers, network. Okay, so think about it from the OSI stack, layer 0 through layer 4. I'll talk about the MSIT function that sits on top of that, but I want you to understand that because from a cost standpoint, there's a bunch of specific reasons and a service delivery standpoint that we're doing that. Second thing, and probably the most compelling part of this presentation, is around our data center innovation roadmap, what we're doing around our Gen 4 specific designs, and those are real. I can show you actually real pictures of them, and I think you'll find that very, very compelling, innovative, and probably a bit disruptive as well. And then the last thing, I'm a NetOp. Ultimately, the way I think about my role, I'm not a product guy, so I'm not up here trying to sell you anything. What I'd like to do is have an open conversation. What are the logical steps we all who are running data center capacity, what are we going to do to figure this thing out called the cloud? And so NetOp to NetOp, I want to have an overview conversation about what I think those logical steps, with no products whatsoever involved in that conversation. So let's start off with the data center innovation conversation. And I like to start these presentations by driving a stake in the ground. Let me introduce you to Chicago. This is a Gen 3 data center for us. I'll show you what our generations look like in just a second. Let me give you some heuristics on the data center. It's been open a couple years. November will be its second year of operation, 707,000 square feet. We have two 60-megawatt independent transmission level feeds. That's two separate power companies that basically support for redundancy. Now, what we've also done is we put power pods or packs basically in place so I can take any part of the data center down for maintenance and have basically a consistent functioning environment. Now, what was interesting is when we went to design this data center, we had a conversation with all of the organization that was basically going to be involved in building this data center. Let me be real specific. At Microsoft, everyone that touches a data center sits in a single org. So facilities, electrical, mechanical, all the vendor contracts, operations, everybody sits in a single org. And the reason we do this is very, very specific. It's the only way you can run a 100% consumption-based chargeback model or a utility. Ultimately, you've got to have those costs. Most IT shops are kind of split up. You know, facilities is over here. You have somewhat of a contract, and IT is a bit disparate. So we brought all those people together. And one of the questions that we had was this was going to be an enormous capital project. It's published, so I can share that it was over $1 billion to put the infrastructure in place before we ever rolled a server on the back patio. So somebody in the room raised their hand and asked a question. Can anybody in here tell us why we're building big refrigerators? Okay? And this was a really interesting turning point, if you will, for us, because what we realized, if we could do something different in this facility and basically lean forward around that and change our designs, we could move away from an enormous amount of capital that we need to put in place every single time we put in a server. And by the way, that capital scales with every server that you basically put in place. The more servers, the more power, the more cooling, et cetera, et cetera. So what we did to kind of distill it down is we decided to break training with Chicago. Now, we didn't put all our eggs in one basket. Upstairs, anybody here been to Chicago? Any hands? Anybody been inside them? Okay, good. We got a couple. Anybody been to another Microsoft data center? Okay, we have a few. So you guys have seen this. What we did upstairs, traditional raised floors. So we basically built colos. There's 12 of these rooms, and we basically run our standard server workloads in those environments. But downstairs, as you can see on the slide, we went to containers. Now, what a container is for my organization, GFS, I buy servers and provision network. It is a single end item SKU that has 2,000 servers in the lower container, and upstairs all of the critical environments gear that basically supports those servers. It's a data center in a box, or in this case, two boxes. Now the difference is upstairs, I'm running 5.9's SLA, okay? Standard, Microsoft SLA for people that are basically running in those configurations. Downstairs, I'm running 4.9's. Now what this means for the application developers and the service teams that are running in those configurations is they now have to use the network for geo-redundancy to basically back up their application and service. So they now use the network for redundancy and resiliency, and they write that into their application. Now, the reason this is so important, and it's a big shift basically in the industry, is as we move forward, and we now start to talk about Windows, Azure, and talk about the cloud, we will require up the stack, if you will, where they write applications and they run services, for the application teams to now take on redundancy and resiliency for that application. If I can have multiple copies in a number of locations, I don't have to have such a strict SLA at the infrastructure. So if I can relax 5.9's at the infrastructure to 4.9's and 4.9's at the network to 3.9's, my OpEx model changes dramatically, okay? So this was a flagship for us to really start to take a look at the industry, the way we were designing, N+2 Tier 3 type data centers, and say, guys, we can do this differently. And if we do it differently, we can operate in a much different configuration, both from a CapEx and an OpEx standpoint. Now, to drive that stake into the ground that I wanted to basically get established before we move on, we're not doing this again, okay? Okay? Ultimately, when I talk about Gen 4, and I'll show you what this looks like, we're not building enormous buildings, okay? The cost of this building, majority of the cost, was three things that have nothing to do with IT. Cement, copper, not copper, Cat5 copper, copper water pipes, and steel, okay? Nothing to do with IT. By the way, 18 months basically to bring it in, under a capital project. We can do that a lot faster now. So stake in the ground, we're not doing this again. So let's have a quick look at where the industry is going, because, and this you might find interesting from a data center guy, but this is a great view of really where we're heading when we talk about the cloud. I just saw the 2020 numbers, and they perfectly line up with what this slide basically says. So ultimately today, if you look at the internet, we're all we're hooked up either via our enterprise or through our public offering, basically to this massive landscape where we all bounce all over the place, and we basically host information, we bring in web pages, we play with the internet with a number of different devices. Stand that up now and make that a vertical interconnect between 16 billion devices on one side and millions of services on the other side. And ultimately, this is where we're heading. And believe me, from a NetOps standpoint, this is a bit chilling, because what it's talking about is concurrent connectivity, probably 8 to 10 hours a day for every device you've got in your bag. And I would venture to say that everybody in this room has at least 2, if not 3 or more, okay? This is an interesting quagmire because we've got some issues around power, we've got some issues around connectivity and bandwidth, and boy, we're going to have a lot of devices basically floating around in this environment. But I think this really gives us a feel of where we're going as NetOps and ultimately what we're going to have to do to support the system. So I want to give you an overview of really what's going on at Microsoft, and I'll give you a timeline here in the next slide. I bet you didn't know we're running 200 services in production. Okay, I'm going to start with 1989 when we opened up our first data center, and one of the things that I'll say is that we basically moved to a service model about 20 years ago. The problem we have right now is we've got a legacy basically of older properties or older customers, clients in my case, that are running in 20 or less servers in specific configurations. And where we're moving ultimately is to more of a commodity-based system. I think you look at people like Facebook and they're running one flavor of server, and I think ultimately Microsoft will get there. But I've got to be a number of things to a number of different people in my world, and that's the reason we federate the infrastructure. That's the reason we have an organization called Global Foundation Services that does nothing but data centers and networks. It's because I've got so many different types of services that basically run on top of my network, things like Bing, that I push out to edge nodes. I drop that content out to an edge node, 24 hours later I write over top of it, and I really don't care much about it. It's low business impact, it's local content, it's usually localized in those capacities. I'll show you what edge nodes look like in just a second. The other side of it is health vault. You got to lock it down and make sure it's absolutely protected. BPOS-F, which is our Office 365 Federal offering, is another example of a very, very tightly controlled network and application capabilities. I've got to be a number of things to all people. So that's the reason we do what we do, and that's the reason we're federated the way we are. So let's start with a brief overview of how we got to this thing called the cloud. So we opened up our first data center in 1989. Okay, quick question. Who was around in IT in 1989? Okay, a few of us. All right. Now this is interesting. This is when we opened up our first data center. Let me describe it to you. Building 11 at Microsoft, it was a room about this size, and we had shelves with compact ProLiant servers as far as the eyes could see, large towers. We were using B and C loop connectors. Everybody remember those? There's probably some in the room don't even know what that is. Cat5 was the technology of the future, and our corporate backbone was CDDI bands. These were copper cables, basically, that were running the network. So we've come a long way, baby. Now, ultimately, what we did at that point in time is we made a conscientious decision as an organization, as a company, and we were only about 12,000 people at that time. I had just hired on to break away from what we called traditional IT and move into an ITIL or a MOF type of service delivery organization. And the MSN Butterfly that you see there, this is when we started our first online service. My organization, which is GFS today, Global Foundation Service, was birthed as MSN Operations. Now, here was why. The model at that point in time was, the IT model, delivery model at that point in time was, they were a bunch of developers writing custom line of business applications. Give me $1 million, give me 18 months. When I get that done, give me another $500,000, I'll run that application in a server room or maybe a closet or maybe under my desk. And ultimately what we realized is that model was not going to scale for services. Services was all about utility-based pricing, service catalogs, single owners, those types of things, consumption units. And so we got birthed and basically have been in place running online services for about 2 decades. We move into the online app era. Now, interestingly enough, those 2 properties you see at the bottom there are 2 services that we run in production, and they were actually acquisitions, basically Windows Live and Messenger and our Hotmail product. Now, I want to make a statement, and I'll probably get a chuckle out of you, but ultimately, as a NetOp, these are services that basically I run for free. You can log on to Windows Live, get a Windows Live ID, and we'll set you all up, SkyDrive, give you, a bunch of disk up there. I want to tell you something that's the reality in our world. Free is expensive, okay? Don't let anybody tell you that anything is free in the IT world. I could walk you through our Hotmail colos, and ultimately at the end of the day, they are not free. And I think it's a precursor of really where we're going towards the cloud. I think it was necessary, and I think there's a number of people that are offering these types of services in the industry. But ultimately, what we're going to want to do when we get to the cloud is really that key characteristic of cloud, which is a measured service, or the ability to basically pay utility-based pricing, pay for what you consume. We move into the web services era, we get big now. We launch a couple of very, very large services. Xbox Live, I don't know if you're aware, one of the largest consumer-facing and most dynamic services basically that we run. Now, interestingly enough, from an I/O standpoint, NetOp to NetOp, it's not as big as some that I run in my environment. One of the largest basically I/O loads that I have on my network, Windows Update. Okay? So ultimately, the reason I want to bring this up is as we move to the cloud, as we start to move out to the right there, we are going to be doing 2 different things at Microsoft, and likely in your IT environment as well. And number 1 is going to be running update domains. We will require that all network operators and partners who are basically managing Windows Azure receive updates. Now, we've seen the success with Windows 7, the ability to basically run the same version, if you will, of that application almost real time. Within a short period of time, everybody receives those updates. We'll do the same thing at the platform as a service level with Azure. The other thing we'll do, fault domains. Now, all of us are very intelligent people. We understand how servers work. And ultimately today, when you talk about failover hardware, you talk about putting a second server next to the primary, right? Now, ultimately, we're going to be doing this in software. And what we're going to be doing in our environment is when you have a virtual machine, whether it's an internal customer or an enterprise customer running on our environment, when that virtual machine starts to go south, it starts to fail, we'll basically propagate that on a new healthy volume, bring it up, and that instantiation will likely not even be flagged unless you need to know it. And so when you start to think about what IT does, our role changes dramatically. We become self-service portal providers where basically all of IT gets provisioned through a UI. We run update domains. We make sure versions are basically consistent across the planet. And we have enough resources, pools of resources basically in place that allows us to run both our internal and external businesses. So I want you to start to think about CPU pools, storage pools, SQL pools, and basically making applications that know about those pools and can make reservations with bursting against those pools of resources. And that's really where IT goes. Now, I know you're probably asking a question, and I'll try and answer it at the end. What the heck does IT do when we no longer hug our servers, right? Ultimately, at the end of the day, we're not going to be playing with routers and load balancers and those types of things. That will be more of a utility-based delivery. What does IT do going forward? And I'll answer that. One thing I like to say about the cloud, and I've been around, obviously, I kind of leaked my age at the front end. I've been around since the PC era. I was the guy at Honeywell that got the first dual disk PC with Borland DBase basically put next to it and said, go figure out what to do with this thing. I think that the cloud era will make the prior 4 eras look like a speed bump. And here's why. Every customer I talk to right now is retrofitting their data center infrastructure. I have a question. I have 2 questions for you, and I'll ask them again at the end. What generation data center are you building, and how big a data center are you building? Ultimately, with the cloud, realize, will you need all of that capacity 5, 10, 15 years from now? Okay? Excuse me, going the wrong way. So want to give you a feel of where we've got data centers. My legal group will not allow me to expose all the locations of our data centers. I think you can understand why. But ultimately, when you buy either Office 365 or Windows Azure from us, these are the large, what we call production data centers that we expose. By contract, we need to tell you what your primary and secondary is. And these are some of our big guys. Now, we're adding a lot of capacity. I cannot give you those numbers, either server or megawatts, but ultimately, we're growing the network in support of a large growth business that we're trying to build out called cloud. And one of the ways we're going to do that is we are going to deploy and are deploying, and have deployed, I should say, CDNs, content delivery networks, or edge nodes. So let me give you a feel architecture-wise what this looks like. Ultimately, we're still going to have our large data centers. I don't want you to think we're going to start turning these off. There's huge investments there, and there's an enormous reason to have large primary and secondary data centers. Things like disaster recovery, failover, those types of things. Still makes perfect sense to have those in the architecture. But when we start to deploy edge nodes now, we've got a flavor of a node that allows us a lot more flexibility and pliability. So as I said earlier, one of the key initiatives that you're going to see from my world, which is basically data centers at Microsoft, to the application and services teams at Microsoft, is I want redundancy and resiliency in the application. Put it 3 or 4 places, so if I lose a node or I lose a data center, I still have service availability. Okay, this is the way we're going to do it. By deploying edge nodes, and we have 2 flavors of these. We have what we call a consumer edge node, which is ultimately the ability to run off an Akamai type model, where we basically buy the service from them, they own the node, they own the pipe to the node, and we have thousands of these running on the globe right now. And then we have Azure Edge, which is a dedicated node. And ultimately, the difference there is in the Azure node, I can guarantee SLA, because I own the pipe and I own the node. And when we start to look at some of the futuristic workloads, obviously the .gov type of workloads that we're going to be carrying, I've got to be able to guarantee that SLA, and that's the way we do it. Now, you can see the reasons I like these things. Geo-redundancy, number 1. Latency, obviously if you put an edge node right down the street, imagine dropping one in this building and everybody's hosting off that or basically getting their service, latency is going to be greatly enhanced. The other thing is I can build these a lot faster and a lot cheaper. They're not billion-dollar data centers. And then the last thing that really, really gets interesting is when we introduce the appliance. Hold off till the end. I want to talk about the appliance specifically, and I think what it does to us longer term, but it becomes an integral part of your architecture going forward as well, okay? So let me give you a feel of the moving parts, if you will, to deliver the cloud, and this is the way that GFS, my organization, basically functions. So let's start up at the top. We do all things data centers. So we design them, we build them, we run them. Now, let me tell you our staffing model. It's relatively unique. Remember my original statement. We're layer 0 through layer 4, layer 1 through layer 5 if you're a telco. So we're basically managing everything up to the session layer within the environment. So what we do is we run our data centers with 3 full-time employees. Data center manager, technical program manager, critical environments manager. Underneath that sits 3 vendor contracts: technical, critical environments, and security. In the case of the first 2, we competitively bid those on regular cycles for SLA and cost reasons. In the case of the third, we use Securitas. They are our global provider of security, not just for our data centers, but for all Microsoft facilities globally. When you talk about cloud security, you want a perpetual relationship with the people that are helping you provide that. Now, one thing I want you to notice about that graphic, there are no cement buildings there. I'm now going to start to shift to talk about pre-manufactured structures that have network spines and power spines down the middle of them, and everything that comes into that facility will plug and play. okay? I'm going to talk about IT packs, and I'll show you what that looks like in just a second. Global capacity, I've already talked about it. We'll be putting smaller nodes in more locations. One thing you may have noticed about the map that we just had up is if you look south of the equator, we don't have a lot of major data centers down there, right? And no one does. Here's the reason. Lack of consistent power, lack of consistent network. Plus, the other problem is the major population hubs are so disparate. You know, you talk about serving Australia, and one of the closest places you have to do that is Singapore. Well, that's not very close. So ultimately, a microsite strategy and putting more nodes in more locations we think will help us deal with that. By the way, if you make a mistake, you can pick it up and move it too. It's a whole lot easier to do that than to move a major data center. Tools and automation. I do an entire session on this right here. Got to remember, in the business that I'm in, and again, I have the luxury that I don't worry about applications. I worry about packets of data moving across the wire. Those are my SLAs. For me, the ability to measure the heuristics of the lowest network device on the network, tell you who's using it, and what the rate against that consumption is all I care about, okay? The reason being, I want to be able to put a consumption statement in front of my end customer, okay? The way that we've changed IT and the delivery of IT at Microsoft and have really positioned ourselves around the cloud is the ability to measure power, storage, egress, and tickets and put it in front of a customer every 30 days based on the consumption of what they pull off the network times the rate of that consumption unit basically on a bill. Now, if you want to get your customers believing that you actually know what you're doing, lock your costs down, okay? I'm going to talk specifically about this. I've got a slide on this. I think you'll find it compelling, and it's an area where I find most of our customers have not even started to think about, okay? Most customers, most IT shops are an allocation, right? 6%, 10% of basically the bottom line of the company. They divide it by the number of people in IT, and that's the cost per head, okay? That's not the way you can do it if you ultimately go to the cloud. The cloud is a metered or measured service, okay? And you've got to have those capabilities. So for us, we put the monitoring in, the ability to basically tie into the financial systems, and we've even taken it a step further where we not only present the cost, we also present the revenue. So basically, we can calculate gross margin for that particular business real time. And again, we can now sit down with our end customers and have much different conversations about IT other than you guys are too expensive, right? We can sit down and say, do you realize if you decommed old servers and moved to new servers, those types of things. Security and compliance. Now, I'm going to step up on my soapbox here. One of the things that really frustrates me about what we're doing in the security and compliance space is that ultimately, if you look at everybody in this room and all of the hosters and NetOps that are basically out there today, we're all getting certified around the exact same compliance frameworks. Okay, the way we approach this is threefold. Ultimately, we risk assess all of the things that will happen, outages, service disruptions, and incidents. Those are 3 levels, and that list is dynamic. It changes almost every minute. So when we have something happen that's a service outage, the entire A team comes together, which is basically all the ops, developer, and service people, and they resolve that outage. At the lower level, incident, that's all vendorized. Those are things like add, move, change, and basically we read a script and close those out. So we stack rank what we do each day, and that model changes. So we're constantly looking at the probability of what will occur and make sure we've got the right approach and the right reaction to it. The second thing we do is we self-audit ourselves. Now, ultimately, we have 300 production test points within the environment, and we test those on a 2, 3, or 4-week cycle. We bring in third-party attestation individuals like Deloitte and Touche to come in and basically say, yes, that's blessed. And then if you come ask me, hey, how does Microsoft run your processes, I have a third-party attested report. The last thing is the compliance framework, and here's where I'm going to step up on my soapbox. Ultimately, we're going after all of them. We have to. We're getting into the ability to be a utility-based cloud provider for you. So if you operate in a military or .gov environment, I've got to have FISMA NIST. We're ISO 27001, SAS 70 Type 2 certified. The list is long. Here's the deal. Every single one of those certifications is the exact same 300 controls that I test. My desire, if you will, from the industry is why can't we basically go after a cloud compliance framework? Because ultimately, every single one of us, including our competitors, has teams doing this exact same work, identical work, by the way, and ultimately, at the end of the day, it costs the end service customer who's basically paying for that. And I think we probably need to look at a tiered approach, which would probably be consumer, military, government, those types of things. We could figure that out as we go. But this is really costing us. It's an enormous amount of work. It's very redundant work. You have to get refreshed all the time. And ultimately, I think this is an area we can improve on and lower our costs and up our service. Thank you for allowing me to talk about that. Now, the last thing, and probably the most paramount, and the reason I wanted to start out with that slide around devices is the dark fiber network. This is an interesting area. We've hired over 1,000 people in the last year just to work on network topology. And here's the problem is if you go out and say, hey, I want to hire cloud network people, they don't exist. They don't. I mean, ultimately, at the end of the day, we're talking about 40 gig networking, right? It's coming. It's going to the motherboard. The ability to redesign your entire network around that single technology is a challenge that not a whole lot of people have thought through. Okay, and ultimately, when we start to look at this area, this is one that we've got to invest heavily in because it really allows us to do different things. So one of the things we've just done is completed a dark fiber network here in North America that basically is an owned network. We've been somewhat quiet about this, but ultimately we think this is the type of work and this is the type of investment we got to make longer term. Now, ultimately, I want to explain my business model to you. If you look in the middle of the slide, the groups that I support, and again, I like to state this, when you do business with Microsoft, you will never do business with GFS. I am a infrastructure as a service provider to the platform and service teams within Microsoft. So you'll write contracts with Office 365 and Azure, and you will get the GFS network implied within those contracts. Okay, you'll basically be riding on my toll road. So my product teams are my customers and service teams. Those are the people that we support. The other group that I didn't mention, MSIT. This is Ron's organization. They run Microsoft Corporation. Windows 7 desktop all the way through the line of business application. They keep us afloat. They're our first and best customer. Now, they do have one onboarding data center. So they take all of their non-production apps, they test them out in their environment, and then basically move them over to our operations environment where they run globally. And then lastly, we're bringing people like yourselves into our environment. And I want to tell you, if anything changes what you do for a living, start to run customer workloads in your colos. It will change everything. It'll change the way you approach work. It'll change the types of people you basically hire into your environment, and it'll change your processes completely. So there's the moving pieces basically around what we do in the GFS organization. Now let's talk about cloud services. As you guys know, the characteristics of the cloud, self-service porter, elasticity, basically measured service, resource pooling, and broad network access. This is one of the key. The third thing I mentioned was measured service. Now, what we've been doing, we started with a service catalog about 15 years ago. We've moved to consumption-based utility pricing for our end customers. So ultimately, the way I want you to think about this is we have the cost of a data center, okay, and it's regional. By the way, we couldn't go specific to the local cost of a data center because everybody in the environment would want to go to the cheapest data center. So we couldn't do that. We've got basically storage. We've got egress, which is basically my IO, and we've got tickets. The ability to be able to bring those into view and understand that IT owns the rate of those services and the customer owns the consumption of those services as a unit, okay? Power as a kilowatt, okay? Ultimately, that changes the dialogue, and if you're looking at that every 30 days, coupled with your SLAs and your OLAs, you've got a very, very distinct relationship between who owns what in the overall cost schema. This has changed everything for us within our environment. We can now sit down with our end customers and say, ultimately, at the end of the day, if you think I'm too expensive, let's look at where the costs are. Do you realize that you're running vintage servers? And if you went to a more efficient footprint, I could lower your power costs, those types of things. Ultimately, this is an area that I think most IT shops want to get to, but have no idea where to start. And again, this has been about a 15-year journey for us to get to this point in time. And again, we've just added revenue to that to allow the gross margin view to happen, basically. By the way, this single focus has changed the entire organizational approach to cost, so much so that we have actually replumbed the financial systems within the company to basically work around this cost structure. I'm quite literally the CFO of the company has changed the way SAP runs within our environment. So this is a big, big change. It's a big shift. And by the way, as a cloud customer, you must require this of your utility provider. If I can't do this, ultimately at the end of the day, you're not going to know ultimately what things cost. And you want to have somebody that has this level of granularity. So let's talk about a couple of measurements, and then I'm going to get into the data center stuff, which is the fun part of the presentation. So everybody in the room probably understands power utilization efficiency. Let me kind of clarify it. Building load over IT load. So if we have a PUE of 2, that means I've got 2 megawatts running at the building level. I've got 1 megawatt running at the IT level. That's not very good. That's not very efficient. Basically, the point I want to make here is we've already achieved with our IT packs, Generation 4, 1.05 PUE. Okay? This is reality. Now, ultimately, I think this is a good measurement, and I think it's one that should be of focus to all IT operators, but it isn't the crown jewels. Ultimately, if you look at Microsoft, Google, Yahoo, and you look at our PUE numbers, we're all running relatively efficient. All it really tells you is how well are we basically using power. And that's a good thing to do. I think that's a good measurement. But in my earlier point, we've almost reached theoretical, which is 1. Ultimately, and we think that there's a need for another measurement, and that's the one you see here at the bottom. Application performance per watt. I want to be able to go to my product teams, or even if you were running an application in our Azure environment, and say, how efficient is that application at pulling resources off the network? How much power, storage, egress, and tickets are you pulling to run that application? Because if I can put those side to side, say on a 1 to 10 scale, I'll be able to say this one's efficient, this one's not. You don't get that out of power utilization efficiency. You're going to see us put up, we actually invented PUE. Christian Bellotti at Pyramine, who sits on my team, was the one who wrote the original PUE white paper at Berkeley Labs, and he was with HP at the time. He's actually going to create the spec you see here at the bottom. One of the things we're working to do is actually integrate this within our System Center environment so you basically can monitor your applications and know how well they're doing. But we think there's a need for this level of measurement because it's the only way you're going to know how well a specific application is doing on the network. And by the way, it's going to be able to identify the dogs, right? You're going to know who's not running well and who's pulling a lot of resources off your net. So that's a quick look at basically metrics. All right, let's shift gears, talk about the data center. So, traditionally, your customers, my customers, everybody that's customer IT, that's what they think a data center is. A big cold room, lots of flashing lights, pretty loud in there, lots of cold air blowing, hot and cold aisles, those types of things. The reality, this is what a data center is. If you talk N+2, Tier 3 redundancy today, all of that stuff has to go in before you ever roll the server on the back patio. Okay, this is the actual pictures of our infrastructure at Chicago. Okay, we don't think this makes sense anymore. We don't want to do this, and ultimately I'm going to get you into the conversation around what we're doing in our Gen 4 designs. Now, ultimately, what we're going to talking about doing is not that radical a shift, but it is a complete different thinking about the way you spend capital within your environment. If you look at the left, we're looking at kind of the traditional approach to N+2 Tier 3 as a kind of a baseline. And ultimately, what we want to change moving to the right is we want to get rid of that carbon-based cooling piece of the pie, okay? It's an enormous amount of cost, and it's where all of that infrastructure basically rides. If you look at all of this, the problem you have with this stuff is, number one, you got to buy it. Number 2, you got to install it. Number 3, you got to maintain it. And number 4, at the end of 20 years, you got to get rid of it all. Okay? And ultimately, at the end of the day, we don't think that makes sense. And moving basically into a model like this, it allows you to spend a lot more of your dollars in IT on actual IT and not on critical environment stuff. I don't know if you're aware, but the amount of usage of the failover systems in most of our data center, 0.001% of the time, majority of that is testing. We run our generators, so we make sure that if we have a problem, they run, okay? Now, the fact that you have 12 diesel generators behind the scenes is probably overkill if you look at that usage. And so we understand this is a bit disruptive, it's non-traditional, but ultimately we think it makes a ton of sense, and you can see the benefit at the bottom. You can get much, much more efficient, basically you can do this. Now, what are we going to replace carbon-based cooling with? Airflow. We're really big on what we call air side economization, which is very simply having the measurement of heat that you're basically pushing through your systems and having ample airflow to move that heat out of the system. And when that is not enough, we want to introduce a concept called adiabatic cooling, which is nothing but water across that airflow. and the ability to drop at 10 to 15 degrees Fahrenheit, basically instantaneously, only in certain situations. And I'll talk about basically what we're doing at Quincy, Washington, which is a great model for where this is going in. So let's talk about data centers, and I want to show you a video. So generation 1, this is basically where we all started way back in 1989. You may have a few of these. We've got a few of these. Ultimately, the problem we have is these were plumbed for 50 watts per square foot. If you're looking at blades and storage arrays, you're at 3,500 watts per square foot nowadays. So you're running out of power, you're running out of space, right? You got a big room and there's one box sitting in the middle of the room. By the way, some of those configurations are getting so heavy now you can't even put them on raised floors. You're going to have to put them on cement because they're just getting so dense. Generation 2, we made a conscientious decision to design, build, and own our own data centers. And here was why. Ultimately, the bleed-in or the carryover from the Gen 1 model, the lease model, was something that we could not pass through to our end product teams. We were getting between 6 and 20% year-over-year growth, cost of power, cost of lease, and ultimately, if I'd have tried to push that through to my product teams, I would have been unemployed. They would have gone out and hosted with someone else. So we built a couple of beauties. Quincy, Washington, San Antonio, Texas, 26.7 megawatts off the grid, large, high-density data centers, beautiful, beautiful data centers, mirror images of each other. Now, ultimately, I go back to my earlier point. We're not going to do that again. $500 million for the infrastructure there, cement, copper, and steel. We've already talked about that. Move to Generation 3, already talked about Chicago. But let me tell you what happened when we went to Dublin. We built a fully redundant data center in Dublin. Walk outside, Christian and I are walking down the street, and here's one of those bank signs that has Fahrenheit, Celsius, Fahrenheit, Celsius. He punches me and he goes, look at that, 68 degrees Fahrenheit here. And I said, so what? And he goes, that's the exact same water temperature that we're basically plumbing through all the copper pipes at Dublin. Very, very quickly, we replumbed the place. We turned the servers around. Interestingly enough, we'd already created these airflow systems. We put the back of the servers where the heat was coming out. Now we pull cold air basically from the outside. We filter it for particulates. We use washers to basically manage the humidity. We run 365 days a year on outside air. Air side economization, okay? We proved out our model in Dublin. We run at 1.2 PUE. We just won Green Grid's most efficient large data center in Europe award, okay? Now, what's interesting, we have a lot of our competitors moving right next door to us right now. And ultimately, it goes to show you that if you can take advantage of outside air, like Quincy, Washington, Dublin, Ireland, you don't have to put massive infrastructure in place. Now, we still have the infrastructure there. We call it spares. Ultimately, but at the end of the day, if we were to design another data center, we'd do it differently. Now, Generation 4. Now, ultimately, pre-manufactured building. Goes together in months, not 18 or 24 months, and the cost of capital is greatly reduced. These are large wind tunnels. The way I want you to think about it is the walls are basically flow-through, cement pad. Now, one of the things I want to stress, and you designers in the room will find this interesting, we didn't want to put roofs over IT packs. IT packs are completely outdoor certified. They could run basically in the middle of a field. Our customers would not tolerate flying over servers. Okay, and ultimately we had to put a structure in place. So the pre-manufactured building became very, very appealing to us because it goes in very, very quickly. So ultimately, network spine, power spine, right down the middle. Now I want to talk to you about what an IT pack looks like. So this is, what you're going to see here is our reference design for an IT pack, IT pre-assembled component. The way I want you to think about this is it's a data center in a box. What I need to operate this is about 640 kW of power. I need 2 fiber channels and a garden hose. Now the reason I need a garden hose is I'm only going to run water flow above 95 degrees Fahrenheit in this demo. Now our actual adiabatic engage point is 85 degrees. We've changed that since this design, but ultimately you only need the water at the high end. So this is the 10-rack version, has all the power conditioning, basically UPS built into it. Those fans you see going in right there are reversible. So when it's hot outside, I'm pushing hot air out. When it's cold outside, I'm basically recirculating the air within the system to manage the temperature inside the environment. 10 racks going in. Now all of the critical environment gear is going in on this side. So we have the same thing I told you we had at Dublin. We have filters, we have washers, and then the water flow system basically is above. Now again, I'm going to put this under load in just a second. We're only going to introduce the water at the high end of the spectrum. Okay? The maintenance you have right there is basically the air washers and the filters, depending on what part of the world you're in. Those have to go in on regular cycles. But again, this seals up, fully outdoor rated, can run anywhere, quite literally. We've decided to put them in buildings, as I mentioned earlier. So now we've got this built. Let's put it under load. So what you're going to see on the left is the outside temperature. What you're going to see on the right is the server environment. So right now we're running on mechanicals, large airflow, right? There's no water, there's no adiabatic cooling introduced yet. It's getting warmer, and again, we've settled on 85 degrees. The demo's going to show you 95. Now we introduce water. Delta T, boom, down 10 degrees instantaneously. And ultimately we'll run this in the part of the day when it's the hottest and basically keep the environment well. Now we get up to 105 degrees outside, server environment's still golden, okay? We've actually enhanced this even a little bit more, and when I show you the pictures of the Gen 4 designs, I'll talk about that. Now we're gonna get to a point where it's cold enough outside that now we mix the internals, okay? We're starting to seal up the box. This has 4 modes, as you can see at the bottom. Those could be the 4 seasons, those could be 4 times a day. All of it is remotable basically within System Center, but ultimately, gives you full control over a capacity unit basically called an IT pack. So for us to add capacity going forward, it's a simple buy. Ultimately, we buy one of these from our OEMs, and I'll talk about that in just a second. And ultimately what we do is we put in very, very simplistic infrastructure, pre-manufactured building, power, and network, and ultimately these blocks just basically go in place. And remember, garden hose, so we're not running continuous water flow, okay? So let me tell you why we're doing this. It's not to win awards. Okay, I'm panicking. Talk amongst yourselves. Sorry, guys. You'd think I didn't do this for a living. So why are we doing this? Ultimately, there's 2 measurements I want you to get out of this, and one we've already talked about, which is PUE. So ultimately, Generation 1, 1.9 PUE, Generation 2, 1.7, Generation 3, 1.4, and as I already mentioned in Generation 4, we're running at 1.05 PUE. Now, when we add a generator, that will basically go up a little bit, but ultimately we're at the low end of the PUE spectrum. But the other thing I want you to think about is CapEx and OpEx. So ultimately, our cost to build out each of these configurations, basically over time, now these are our numbers, your mileage may vary. CapEx, let's talk about Generation 1 at 25 million per megawatt, Generation 2, 18 million per megawatt, Generation 3, 14 million per megawatt. I'm building out Generation 4 capacity today at 10 million per megawatt with an 8.5 million per megawatt goal over the next couple years. So ultimately, we reduce the cost of capital by 5x. But remember what I said earlier, if you're not building a bunch of critical environments gear in the back of the house, your OpEx goes down by 60%. You're not playing with generators and UPS rooms and diesel in the ground and water treatment and evaporative systems. Everything you need to run IT is inside that box, okay? So this is why we think this makes sense. So ultimately, we're building out these Generation 4 configurations in 4 locations right now. Quincy, Washington, Boynton, Virginia, Des Moines, Iowa, don't ask me how to spell Des Moines, and Dublin, Ireland. So what's interesting, if you want to go see these configurations, I'd love you to take a trip to Quincy. And if you ever want to do that, get with your Microsoft account rep. We've got the ability to take customers through these environments. And you can see Generation 2 and Generation 4 in the same site. So I'll walk you through a colo, traditional colo, let you see what that basically looks like and what our scale units look like, then walk you across the parking lot and let you see Gen 4. There's nothing like touching the cloud. Okay, and ultimately when we start to talk Generation 5, we're going to remove all things that spin. When we start talking Generation 6, which is a number of years away, we're talking probably decoupling the data center. So I don't want you to think we're done at Generation 4. We've got a lot of thoughts about how we can do this differently, because when you're 6 to 10% of the cost of an entire company, OpEx and CapEx, you want to look at things differently. And ultimately, when we look at the utility position we have to take to run cloud, it's the reason we're doing all of these things, not to win awards, okay? So here's the design. Now, I want to get your head around the way we do business. We leverage vendors, okay? We work with our OEMs. Ultimately, at the end of the day, we don't, quote-unquote, white label hardware. This is the original design of the IT pack. So this is the engineering that we did to prove out adiabatic cooling and basically run in these small form factors configurations. So think of this as a proof of concept that we basically put out to the street in a specification form. So we basically say it's got to have these ins, these outs, it's got to run on this amount of power. Basically, this is going to be how it operates. Now, what's really compelling is we give that out to our OEMs and allow the OEMs to do what they need to do ultimately inside the box. So the form factor for us needs to be this high and this wide. Show us what you're basically going to do to realize that spec. So ultimately, at the end of the day, we're not really sure what the OEM is going to come back with from a form factor standpoint. So let me show you what the first instances of IT packs look like. Ultimately, let's talk about the facility quickly first. I've already told you pre-manufactured building is what you see here. There's the network spine. Now, I don't want to paint a picture that the only thing we're going to be plugging into these environments is IT packs. There's nothing like a pre-manufactured colo room. Well, why can't that come in a box as well and use air side economization systems basically to feed the room? So IT packs for standalone, and then pre-manufactured colos are another way to go. Okay? Now, here's what the first iteration of IT packs looks like from our first OEM. There's the building. As you can see it, it's a pre-manufactured steel building. It has sliding doors, and I said it's a wind tunnel. It's a flow-through environment. Down below is the exact same unit you just saw, proof of concept, now realized in a scale unit from our OEMs. Down below the IT, 2,000 servers plugged into a common backplane. We've pulled all of the fans from the servers because we've got massive air handling unit above it, so we don't have to have the local fans. Generate a little bit more heat, add more air handling, and you basically can deal with that. It takes the cost out of the server. We're also running a very, very generic server in this configuration. I'll talk about that in just a second. On the right is the adiabatic cooling system. Now remember, in Quincy, Washington, where we're basically installing the first iterations of these systems marry up, by the way. They're not segregated. They actually come together in a single unit, and I'll show you that in just a second. We will run that about 8 weeks a year. And we'll only run it in the hottest parts of the day, which will probably be from about noon till 8 p.m. during those 8 weeks. And the rest of the time, we have no water flow. So back to my point about OpEx, when you're not running consistent water flow basically through your environment, your cost of operations is going to come down dramatically. And again, we need very, very low quantities of water to boot. We're not running high volumes like we do in our Generation 3 and Generation 2 configuration. Now, if you want to see basically what that looks like in a form factor, this is a pod, which is 2,000 servers, which goes into a deployment unit, which is 4 pods. So basically what we did with the OEMs is say it's got to be this high, and we take the heat out the roof. Obviously, we basically ballast it that way, and we put 4 of these in place. So understand that the model that we've moved away from is building all of the critical environments gear and maintaining them ourselves to now buying that all in a pre-manufactured box called an IT pack, and the OEM now has to deliver that to include setup, verification, maintenance of the systems, replacement of servers 3 years, and I can recycle an IT pack 3 times within a 12-year period between 3 and 4 years, and then at the end of life, they're responsible to remove that equipment. That's the way we write the contract, so we don't have to be in that business. And ultimately, as we start to talk about appliances, I believe that you will start to look at these same type of devices as you move towards the cloud. Now, ultimately, I can put 8 of these deployment units in a single building. I'm building 3 of these buildings, which is 160,000 servers in our first buy. Now, I know our server capacity, and you'll ask the question, how many servers do you have? I can't answer it, so I ask you not to answer it. And ultimately, I don't think that would really tell you anything. But ultimately, the more important metric is we buy between 2 and 5% of the servers manufactured in the world every quarter. So ultimately, for us to move to these type of models, which are commodity-based, standard-based servers in these IT packs that basically are self-maintaining, makes a ton of sense for us longer term. And again, Boynton, Des Moines, Iowa, Dublin, Ireland, and Quincy, and then we'll be moving to Generation 5. Okay, so a couple things I want you to think about as we really move towards the cloud, and I'll wrap up and let you guys ask a few questions here. one of the things that we've done around really changing our focus around becoming traditional IT to now becoming more commoditized IT or cloud IT is really to get away from the concept of thinking about the data center at all. The IT pack is really the realization that ultimately we care about the server. And ultimately that server, that scale unit is what IT should be really, really envisioned around. And ultimately, if you can put it in a self-service portal and have people basically provision VMs within minutes, I think ultimately you're halfway towards the cloud. But this is a big change in focus. I talk to a lot of people, and they ask, what do we do with IT when the cloud happens? And I said, you're worried about your server huggers, right? There's guys in your organization, more hardware, right? They don't want to let go of that server. And I think this change to move up the stack and really start to think about software redundancy and resiliency and really to think about that server lifecycle as being very commodity-based and very, very uniform. We don't have custom servers all running all over the place is a big, big change. The second one really came from my boss's boss, Dane Sampson, which is our CVP. He came over from Yahoo. And it was kind of interesting. He said, ultimately at the end of the day, it's not about servers. It's about service availability. And if you look at a company like Yahoo, they think about that service availability each and every day. And if and when it goes down, it changes everything within their corporate environment. And ultimately, I think this focus is one that most IT shops are not ready to move to, because ultimately it means you know your costs. You do have commodity-based environments where you're buying a uniform type of system that basically goes in place, and IT really is a commodity-based service, not a custom service and an allocation as we talked about earlier. Already talked about application performance per watt. We got to move there. Now this next bullet I think is really fascinating. If I look at my 20 years in the industry, actually 30 years in the industry, 20 years with Microsoft, we've been a highly leveraged vendor model. We've really, really pushed on our OEMs longer term, and many of them downstairs basically in the booths. I see the cloud as making new bedfellows. And ultimately, I think when we talk about where we're going and what the network's going to look like and utility-based computing and those types of things, I think it's an opportunity for all of us to look at our business models. And one of the things I like to coach customers on is ultimately at the end of the day, if you haven't rationalized your cloud plan, you haven't rationalized your vendors. Because just to go buy new hardware and virtualize it is not the cloud. And ultimately, I think really understanding what that roadmap is and who are the partners that are going to get you there is a different conversation than we've had over the last 5 or 10 years. So ultimately, I think this is a critical juncture, and I think the new business models will ultimately emerge. And then the last thing, the value of cloud IT, what are you doing in this environment? Move up the stack. You're not messing with servers. You're not playing with load balancers and switches and routers and those types of things. You're maintaining self-service portals. You're putting resource pools together that your end customer basically can provision on demand. And if you haven't thought that through, it's a completely different environment than what you're in today. And it really is the consumerization of IT, which is kind of the industry buzzword that's out there. Okay, just a couple more slides. Ultimately, what are the steps we will all take to figure this thing out called the cloud? Step number 1, what am I running in my data center? I talked to an individual the other day that had 247 data centers. He had over 100 different IT functions. He didn't have a clue what he was running from an application stack, okay, let alone what it cost. Now, ultimately, I think what you're really trying to do here is say, hey, what's my application portfolio look like? And it's probably very, very heavy with custom line of business applications at the top, and it has some commodity stuff down at the bottom. And I think if I would give Microsoft a ding over the last 2 years, it was our inability to plan for that low-hanging fruit, if you will, that's cloudable around email, around SharePoint, and those types of things. Customers have found an enormous amount of value of getting that stuff out of their data center and running it in a cloud environment, hosted either SaaS or PaaS from us. And ultimately, I think what you find when you do that analysis is I've got some things I shouldn't be running in my data center. I'm not a mail expert. Why don't I let somebody like Microsoft run that? I can give back servers. I usually can move to the latest version of the software because I'm usually 2 or 3 revs behind. I can give administrative functions back to the work pool. And ultimately, at the end of the day, there's something I gain that I may not have today. I know my costs because ultimately, I'm going to get a bill. Okay? Now, once you've done this and you've got your application portfolio and you know what you're going to move out of your data center, now you move to the virtualized data center. I want to talk briefly about virtualization. I know you're getting every vendor on the planet that knocks on your door and tries to sell you stuff. Virtualization is an efficiency play. I'm an IT operator. I want to run more efficient systems. It isn't cloud. And ultimately, at the end of the day, I think you need to make a decision as to what generation data center do you need and how big a data center do you need. And ultimately, that's a decision about what apps am I going to keep in-house, what's the stuff I need to maintain, and what does that new environment look like. Does it run in packs, or do I basically run another, tier 3 type data center and basically bring in blades and storage arrays? And again, those are decisions you'll have to make as you move towards the cloud. But again, what generation and how big do you need longer term? And that's not an easy thing to figure out at this point in time, because I think the speed of the cloud realization will be very, very dynamic over the next 3 to 5 years. Step number 3, application migration. One of the harsh realities to all of us is that the applications we're running in our environment today, specifically those that run on monolithic mainframes, don't know what the cloud is. Okay, they don't know about things like edge nodes. They don't know about measuring. They don't know about how services basically get deployed. And ultimately, I think this is the biggest challenge for us, is how do we move off of large enterprise type of systems, and I'm an old mainframe guy. I know they run 30% more power and 30% more cooling than distributed systems do today. How do I move my applications into a more distributed environment? And in most cases, we're talking about application rewrite. Now, the good news is what we're trying to do with Windows Azure is no matter what programming language you basically program in, you can write into our API structure, publish and basically compile in our API. It will go back behind the scenes and reserve CPU, storage, SQL, and the network on your behalf and run your application in that environment. One of the things I like to say is and again, I'm not trying to sell anything, if you don't have someone in your shop looking at Windows Azure, you need to. Our entire company's making an enormous investment here, and ultimately, it's so you don't have to basically provision that infrastructure unless you need to. And ultimately, when you look at the size and the scale of our network, which, by the way, the Cisco report just came out the other day. If we were an ISP, we'd be the 5th largest network in the world. Okay? So massive scale, and again, we're investing in a number of data center capacity projects and network projects to make sure that infrastructure provisions applications where they need to be. Now, the last step, let's talk about the appliance. This is a big change, and there's a lot of conversation. If you go search on Cloud Appliance, you get a whole list of vendors who are talking about it. I want to talk NetApp to NetApp. Ultimately, at the end of the day, I think you want to get out of the hardware business. And ultimately, I think the appliance allows us to do that. So imagine I deliver a device to your back door. It has a 3-year life cycle. It is a run local data sovereignty box. What I mean by that, it has CPU, storage, and SQL pools available to you local within your environment. This runs in your shop or in your partner's shop, and basically your application developer or cloud developer now will publish applications to that box locally and run within your firewall within your enterprise. But if he wants to make or she wants to make a call against a cloud platform and run that in a cloud environment, basically those same sets of resources will be made available. The difference being is if I need to make a call against that data sovereignty box and grab PII or DCI type data basically that you're running in your environment, it's based on your group policies. Okay? So your application developer says, I'm publishing cloud, I'm going back to grab that information, maybe it's financial data for a annual report or something, and I'll publish that based on my profiles and my policies basically out to the cloud. That's what the appliance does for you. It allows you to have data sovereignty within your environment, protect it, run applications there, and basically run cloud when ready. And ultimately, if I can put that on a 3-year OpEx refresh, I get you out of the CapEx business. And ultimately, I think that's ultimately what you're going to want. The speed of innovation, when I look at 40 gig networking and all of the things that's going to happen, solid state drives, I doubt that everybody in this room can move through that cycle as quickly as someone like we're going to be able to move through it. And if we can generically make this appliance and make it available through our standard OEM channels, our good partners who've been with us all this time basically building out this business, I think it's a good thing for the industry. So I think the appliance plays a big role in the future, and you'll actually start to hear lots of press about the Azure appliance in our world over the next 12 months. Now, ultimately, what happens down at the bottom there is the platform moves from an owned platform to a cloud platform. Now, ultimately, will everybody move to the cloud? I don't think so. I think there'll be a number of hybrid models, and ultimately, I think you're going to want to keep data in your environment. I don't see that changing. I know there are other providers that want to put everything basically up on the cloud. I think the appliance basically is the right way to go, at least for the short term. That may change longer term, but with the security profiles and the changes that are happening around criminal compliance in the network, I think you're going to want to keep that data locally. And ultimately, the only role that changes there is that the application developer now is writing cloud versus writing local. But that application developer is really in a different world because he's thinking about services. He's thinking probably about daily drops versus I'm going to build an application and ship it 18 months from now, and basically maintaining that service on demand. And we think this is really the logical steps that will happen there. Last slide, really want to just kind of give you a preview of everything I've talked about. Data center is a server, service is not servers. Think airside. If you haven't thought about it, please come to Quincy. I'll show you what we're talking about. Believe me, I walk you inside one of those things, and for those who would be wearing skirts those days, you'd have to hold them down because the massive airflow inside those systems. We think this makes a whole lot more sense than having water towers in the back. Rationalize your partners, already talked about that. And then plan for innovation. If you're not looking at 40 gig, it's here. It's going to be on the motherboard pretty quickly. It's going to change all of our worlds. Network topology will change with that specific technology. Solid state's going to change. There's some interesting limitations in that environment. We're doing a lot of case studies. We've got some white papers that we can basically share. IT value prop, self-serve, move up the stack. Remember, free is expensive. Ultimately, IT needs to move into a utility-based model. Think about resource pools. The other thing I want you to think about is basically powering to sleep, not off, your data center. One of the nice things about edge nodes and running a global network is we're going to look at a follow-the-sun model. Everyone in this room has powered up their data centers, and we've never turned them off. That's crazy, isn't it? But ultimately, if we could take that, when India comes up, we bring it up to full power, full production, the U.S. comes down, sleep state, not down. You never turn electronic equipment off, but put it into sleep state. We see a massive opportunity ultimately to change the way we utilize and consume power. Okay, monitoring, we already talked about that. And then this last one is really important. We got to think about security at all the layers and all the levels, and we got to simplify the compliance framework. Ultimately, fill out an evaluation. You guys know all about this. This is the last slide I had. And I'd be happy, we've got about 10 minutes left. If I got any questions, be happy to take some of those. If you guys wouldn't mind, could you I guess I can repeat the question, but if you could, the microphone would be great.
You didn't talk about storage and backup inside that. I'm supposing that's only server. Are you putting like storage and everything in those containers?
Okay, so let's, most people today, when they think about storage, it's two things. It's a massive array of equipment, and it's a separate network channel that we're all basically running. Now, ultimately, when you start to think about cloud, you think about commodity-based systems. So why can't that be pizza boxes, as far as the eyes can see, running the storage channel in the main network? Now, that's not going to be for everybody. But the reason I didn't mention it is I'm thinking commodity. Now, also remember, the reason I don't think about it is I'm up to layer 4. The application teams above me will design how they basically approach a storage integration. So to say we don't use SANs, that's crazy. We do. You know, SharePoint as a service, yes, SANs. But ultimately, as a NetOp, the reason I didn't bring it up is it doesn't fall into my space from an operational standpoint. Make sense? But look at commodity, and I think that over time will play itself out. Yes, sir.
So two quick questions. One, when you look at heavy compute loads, and we talk about commodity boxes, how do you adjust for that? Or do you force the developer to do things differently?
Fortunately, I don't have to answer that question. That would be, that would be the Azure team. You know, what we're doing in that space, there's a lot of people at Microsoft that are very, very focused, all the way from the research to the Azure side. And I don't want to dispel your question. Ultimately, I'm not the one to answer it.
And just another light question. I was noticing on your PAT graph a little earlier on, lighting went from like 3% to 11%. What caused that to change so drastically?
I don't think I can answer that. No, I mean, that wouldn't make it. There you go. There you go. Thank you. Nobody's ever asked me that question. Thank you. Thank you.
So this is a follow-on question to your first question.
PUE. Yeah, same lighting, but less consumption of power, so it becomes a bigger part of the pie. Make sense? Yes?
Okay, so this is a question that kind of is a follow-up to the first question, which is the general industry, including Microsoft, is starting to really push the use of specialized appliances. Tell me how this fits into your overall vision with commodity hardware where you have everything as general.
Well, if I would fast forward to the realization of Azure as a platform, ultimately I want to think about resource pools. The appliance will basically be how that is realized, I would envision. So, CPU storage and SQL as resource pools. The most logical way, and I think the way we will realize that, is to have those types of appliance utility devices basically that take care of those workloads, and probably one that does all three. So that's the way I would think about it. Now, again, back to my earlier question, I don't worry about that at Microsoft. Those designs would basically come from, we're working on a SQL appliance right now, ultimately, and that would be a database-oriented type of device. Okay? Any other questions? Yes, sir. Okay, so the question around Gen 4 backup power, passive UPS inside the box. Okay, so that basically be there, and then we are putting generators behind the systems basically in Quincy. Okay, so that 1.05 PUE is the raw box. You'd have a hit to your PUE basically putting that in place, but we haven't dove off that cliff yet. Okay. Anything else? All right, guys, thank you so much for your time.